Here we have AP calculus AB problem. Okay, let's go to the question. An equation of the line normal to the graph of y equals to secant x at the point pi over 4 comma square root of 2s. Okay, so there is a formula to get equation for line which is normal to the graph. Let me write the stuff over here. Equation of normal line. Let me write it. Okay, the formula is y negative y1 equals to negative 1 over m times x negative x1. So here is the formula to get equation for line which is normal to the graph of any function. Okay, here x1 comma y1 is the point at where we draw the normal line to the graph, and here negative 1 over m is the slope of the normal line. Actually, this m represents the slope of the tangent line. Since let me draw the curve here. This is a curve, and now let me draw a tangent line to this curve. I've drawn tangent line to the curve here, and usually the normal line will be perpendicular to the tangent line. So for example, if m is the slope of the tangent line, and for this normal line which is perpendicular to the tangent line, the slope will be negative 1 over m, and this is a point x1 comma y1 at where we draw both normal line and tangent line to the curve. Okay, so we need the point x1 comma y1 and the slope of the tangent m. Okay, once we get the slope of the tangent line m, we can plug in the value of m over here to get the slope of the normal line. Okay, already we have the point that is pi over 4 comma square root of 2. So we can plug in this exponent pi over 4 for x1 and square root of 2 for y1 over here. But we need the value of m. M is the slope of the tangent line. Okay, from the equation of the curve, if I want to get the slope of the tangent line, what I have to do is I have to find the derivative. So now let me take the given equation, that is y equals to secant x. Okay, now let me do derivative on both sides with respect to x. When I do so, I am getting dy over dx on the left side. The derivative of secant x is secant x times tangent x. This dy over dx represents the slope of the curve. Okay, when I consider the slope of the curve at this particular point x1 comma y1 at where we have drawn the tangent line and normal line, so the slope of the curve at this point x1 comma y1 is equal to the slope of the tangent line m. Okay, now let me get the slope of the tangent line m at this point pi over 4 comma square root of 2. For that, we have to plug in this point into the result of this dy over dx. The first derivative, we got it from the equation of the curve. So let me write it dy over dx. So the point pi over 4 comma square root of 2. Okay, so we know that dy over dx equals to secant x times tangent x. Let me write the stuff over here. Okay, now let's write the point pi over 4 comma square root of 2. Okay, now in this secant x tangent x, we have to plug in the point over here, but we don't find y over here, we just find only x over here and here. So we can plug in this exponent pi over 4x over here and here. Then I'm getting m equals to secant pi over 4 times tangent pi over 4. Okay, what is the value of secant pi over 4? For that, we can get the value of cosine pi over 4, because cosine is the reciprocal trigonometric ratio of secant. Once I get the value of cosine, I can get the value of secant. Usually we remember the values for sine, cosine and tangent for the three basic trigonometric ratios. Okay, now let me write the value of cosine pi over 4. So its value is square root of 2 over 2. Then the value of secant pi over 4 is the reciprocal of this value, that is 2 over square root of 2. Okay, now I got the value of secant pi over 2, secant pi over 4, that is 2 over square root of 2. The value of tangent pi over 4 is just 1, then we get m equals to 2 over square root of 2 times 1 is just 2 over square root of 2. Okay, now I got the value of m. Okay, now let's plug in the stuff we have over here in this equation. So that is y negative, the y1 in the given point is square root of 2. Let me plug in square root of 2 for y1. Negative 1 over m, just now we got it, that is 2 over square root of 2 times x negative. The value of x1 is pi over 4 in the given point, the exponent. So the exponent we can plug in for x1 over here. Then we get y negative square root of 2 equals to, we can write the numerator negative 1 as it is. We can change this division as multiplication. When I change the division over here as multiplication, I have to get reciprocal for this fraction 2 over square root of 2. So the reciprocal of 2 over square root of 2 is square root of 2 over 2 times x negative pi over 4. Then we get y negative square root of 2 equals to negative 1 times this fraction is still we get negative square root of 2 over 2 times x negative pi over 4. Okay, now let's check in which option we have this stuff. Okay, I don't see this one in any of the options. Particularly, I don't find this stuff negative square root of 2 over 2 in none of the options. Okay, so when I consider this one and this one, this is equivalent to negative square root of 2 over 2, because we can do a simplification over here. Let me consider negative square root of 2 over 2 equals to negative square root of 2. In denominator, we can write this 2 as square root of 2 times square root of 2. Then this square root of 2 will cancel. We get negative 1 over square root of 2. So that is this stuff for negative square root of 2 over 2 is equivalent to negative 1 over square root of 2. Let me write the stuff for here. Y negative square root of 2 equals to, instead of that we can write negative 1 over square root of 2 times x negative pi over 4. Okay, now I got the equation of a line which is normal to the given graph, and we find this equation exactly in answer choice B. The correct answer choice for this question is B.